Hello there. Today we will learn about 1 is to 4 demux using Verilog. So, what is Verilog? As we have learned, VHDL also is a hardware description language. Similarly, Verilog is also a hardware description language used to model and simulate the electronic systems. So what is it is used for? It is used to design and verify digital circuits, including application specific integrated circuits and FPGA. Now what are the key difference between VHDL and Verilog? So first of all, the purpose is that VHDL was written as a description language while Verilog was written as in a hardware modeling language. Also, the main key difference is that VHDL has a non-C like syntax while Verilog is similar to C code, and the data types of the VHDLs are complex data types while Verilog has a simple data types. So next, we will learn how to write 1 is to 4 demux in Verilog. So we know that 1 is to 4 multiplexer has one input line, two select line, and four output lines. And the it is given here. We can see the block diagram and the truth table of 1 is to 4 demux. So we have input I, select line S1, S0, and output line as Y0, Y1, Y2, and Y3, and here is the required truth table. Now in the next step we will see first of all we will see steps to create a Verilog project. Now when you go to Xilinx, you have to just file, then open a new project. You can see, now give the project as 1 is to 4 demux, then select next, then check the product category, family, device, package, then press next, then new source. So here is the, we have in VHDL we have selected VHDL module. Now in Verilog we have to select Verilog module, give the name 4 is to 1 demux T. You can give any name, but the case should not be uppercase, and there should be not a hyphen between. Now click next, and here you can give the port name as select line, input line or select line, and output Y0, Y1, Y2, Y3. Here I have created already I have created a module of demux 4 is to 1. Now we will go to PPT. Here we will go to PPT. Now next step, as we have created now a Verilog project file, you have well known how to create a Verilog project file. Next step is the code, and it is the most important part here. Now we will see each of one syntax and how it is used in Verilog. So first we will see module definition. Here as we can see, here is a module demux. Demux2 is my file name. Now syntax is the module keyword. Keyword is used to define a module followed by the module name demux2. Now I have defined the ports input 1 to 0. Select, it is here it is declared the 2-bit input called select and used to select one of the four outputs. Input I as select bit input, which is the data signal to be routed, and output as Y0, Y1, Y2, Y3. So here it is only when we declare, here only the new keyword is module. Okay, now next is important one, always block, and it is starts with always at the rate asterisk. Now it is determined the output based on the select line. Here is the main syntax keyword always at the rate asterisk. This block describes the combinational logic, means it executes whenever any input signal change. It is the main part. So first of all it is given as y0 comma y1 comma y2 comma y3. It initializes all the four outputs to 0 at the start of the block, and the notation 4 comma b00 represents a 4-bit binary number. Now third one is the case statement and the end of block and module. So here we have written the condition of our code. The case statement evaluates the value of select lines and direct the input I to the appropriate output based on its value. Now TB0 binary 00, I is sent to Y0, B0 by 01 is sent to Y1. So here is the main case. If select line is 00, I goes to Y0. and if select line is 0 1, it goes to y1. Similarly for y2, similarly for y3. Here we have just seeing the how it is written in Verilog. Here the keyword is case, as you can see, and in bracket select. And if there is a default case, we have to not uh, write it in the code. Now if the case is over, we have written the condition. Now it is here that end case and then end, and last and to end module, like we have end behavior in BSDL code, we have used behavioral modeling to end behavioral, like that we have used here end module. Now end closes the always the block, and the end module concludes all the entire modular definition. It is very important. So here is the 1 is to 4 demux code. It is written like this. Now how we can create a test bench Verilog. Now we will go to similarly we will go to Xilinx. Now here tap on behavioral simulation, then new project. Now here is the main Verilog text fixture. Now as when you created this file, now the file will be open like this. Now so here I have written the code already. Now this is initial begin. Here it is end module, and here are the condition I have written, and the time scale is from 1 nanosecond to 1 picosecond, and the inputs outputs are defined. And when I go to simulation, I will see the simulation of 1 is to 4 demux. And I hope you understood all the concept of 4 is to 1, 1 is to 4 demux. Thank you very much.